Well, good afternoon, everyone. Welcome to this session, which is using OpenStack for managing a Data Analytics HPC Cluster. My name is Ray Scott, and I'm joined today by Robert Budden. We're both from the Pittsburgh Supercomputing Center, located in Pittsburgh, home of the Cleveland defeating Steelers. If there's anybody from Cleveland in the audience, okay, you can all stay. And then, no, seriously, in case you're not familiar with the Pittsburgh Supercomputing Center, we're a joint effort of CMU and Pitt, and coming up on our 30th year of operation. We receive support from many institutions, organizations, government agencies, primarily from the National Science Foundation. In addition to running high-performance computing systems for the NSF, we're also a part of a program called Exceed. Just wanted to mention this briefly. Exceed is an umbrella organization. It's a program that the NSF has to bring together supercomputing resources from around the country and make them available in a coordinated way to the national science community. So we serve as one of the partners in the Exceed program, both from a staffing standpoint and also from providing computing resources. If you have more questions or interest in the Exceed, there is an Exceed booth at Supercomputing for those that are heading over there. The subject of our talk today is a new supercomputer that we're building at PSC. The name of the computer is Bridges, owing to the great number of bridges that we do have in Pittsburgh. Pittsburgh has more bridges than any other city in the world, beating out Italy, I think, by 3, we're told. The theme of the Bridges computer, communities to data workflows and insights, the idea is to be bringing computing in, or supercomputing, to groups that have otherwise not used supercomputing resources in the past. If you think back, or what you may think of as supercomputing or high-performance computing, these are examples of computing applications that we have enabled over the last 30 years. They range, just as you would expect, from biology, chemistry, climate, weather, across all the sciences. But what we have seen in the last several years is a shift, at least not necessarily away from, but in addition to that, new areas that want to get in and be using supercomputing. So where we used to have much more structured data, scientific visualizations, worrying about optimization, more recently, more of our users are coming to us with a lot of unstructured data that they would like to have, machine learning, some graph analytics, some what have been non-traditional spaces such as video and sound analysis. So what we were trying to do when we build the Bridges system is to accommodate these newer users using some of the technologies that we've used from the past. Our partners in building this new computer, first Hewlett-Packard Enterprise, providing the compute servers and also the overall coordination for the design and installation of the system. And then Intel has played a significant part with us. Of course, the CPU technology is important. One of the flagships of the Bridges system will be the Omni-Path interconnect, or the OPA. We will also be making use of the Lustre file system. PSC has been a Lustre site since early 2000s, and we will continue this on Bridges. And then the third partner, Supermicro, will be providing the storage servers for us. I mentioned the Intel Omni-Path. The Bridges machine will be the first large-scale deployment of Omni-Path. I know there were some sessions earlier in this forum on Omni-Path, so won't get into the details too much here. It's a 100 gigabit interconnect. What we really are anxious to work with is the message injection rate, very high message injection rate compared to other technologies, so 160 million MPI transactions a second. And also for building a system like Bridges, the fact that it's a 48-port radix switch ended up being very good for us. The higher the radix, the easier it is to build these systems. So those features have made the Omni-Path very important to us, and like I say, we're anxious to give it a whirl. Sometimes we're not anxious to be the very first to be trying it, but we're getting real good support from Intel. So if we look then at the kinds of applications that we're going to be running on Bridges, this is a long list of the user applications that will be coming our way. I've underlined just a couple, but the theme that you can see there is in the analytics, and then taking people who have been pretty successful running applications on their laptop, maybe using R or just some personal database, MATLAB, but now they need to scale this up to a much larger data size. So we're working with them to have a lot of in-memory databases. So one of the themes that you'll see on Bridges is large shared memory nodes in the system. And again, long list of applications. A couple that I've underlined here, the causal relationships, so moving beyond just simple regression testing and even to some degree moving on from the current machine analytics to really finding causal relationships, relationships in the data that might not otherwise have been apparent and being applied first to the cancer genomics area and then to other bio areas as well. And these are very memory intensive applications. We've had some experience with these on our prior on a system that we just decommissioned, also a large memory system, and so we'll be able to take that forward at a new scale with Bridges. The video analysis is a very big topic for us right now, so just going through video frames, doing recognition, facial recognition, event recognition. We've had some work going on there, and we expect to be able to expand that as well. And then just analyzing the large corpora. We have a researcher who is an expert in Slavic languages. Pittsburgh has a very rich history in Eastern European cultures, and but the volume of work that he was trying to do on his laptop was not going to be able to be processed pretty much for the rest of his career. So using Bridges, he's going to be able to bring that timeline in quite a bit. So, and then another change that we're seeing in a system like this is in the past where people have come with a program and run through a batch system and expecting to get a result. More and more scientists now want to come and use a gateway, have something that has all the applications in place for them and be able just to tune some data sets in and then look at some results coming out. We have a demonstration going on at our booth using the Galaxy software, where some of the data streams, some of the workflows involve 50 or 60 different programs needing to run in just the right order and of course over time be reproducible. So all of these factors building into gateways that we will work with the users and help them develop and have the tools on the Bridges system to do this. And again, in the sort of high productivity programming area, we'll be moving away from what in HPC has traditionally been a C, C++, Fortran world, and making available some of the languages, again, or programming environments that people are used to from the laptop world. So these are just some examples of what we will be doing. And of course also providing a rich big data ecosystem. I call it the Hadoop system here, but it's really all of the ecosystem that goes along with the current big data work. We will provide acceleration and support for that on this system as well. So as we start to put the system like this together, it does represent a lot of new challenges for us. Wanted to mention, so there's a lot of software going through this and a lot of new applications and new tools. All the Omni-Path software is new. So it's a big help to us. We have joined with the Open HPC Consortium, which is a group that's being driven by Intel and supported by the Linux Foundation. and it's going to provide some packaging of some of these tools so that everybody doesn't have to experiment and work to get their own packages or their own package system in place. You'll see several announcements of this around this week, maybe have seen some already. So I would invite you to look up the Open HPC Consortium, and I think from there you can get a good idea of the kind of work that's going on bridges and other places as well. So, and this is a pretty picture. This is a baby picture of the Bridges machine. It's about 800 nodes and then other size nodes going up from 128 gigabyte nodes up to nodes that have 12 terabytes of main memory. So in addition to the kind of work that we'll be doing in the Open HPC, it's presenting a new challenge for us in system administration and being able to build and manage this system. So early in the project, we adopted the OpenStack technology as a way to take us all the way from booting the system up through managing and running all the different software stacks that we're going to have to provide to be successful on this project. So next, Robert Budden, who's been our chief person working on the OpenStack deployment, is going to talk to you about some of the issues and challenges that he's facing in giving Bridges all the different personalities that we have to have on the system. So I'll introduce Robert.
Hi, so I'm going to talk to you a little bit about how we're trying to build Bridges. So with the deployment this big, we kind of looked at it with some challenges. How do we want to support these heterogeneous environments, these different complex workflows, but also being able to support our traditional HPC backgrounds. So we looked at OpenStack. We've been playing around with virtual machines, but then also some of the newer projects like Ironic that have coming up and becoming more stable pieces. So we looked at all of our different support goals. We want to do bare metal provisioning. We want to be able to support virtualization. We want to be able to support Docker containers. We want to potentially be able to integrate with users that may be coming from Amazon Cloud or other OpenStack deployments that just want to run on different hardwares that we may have. We also see a large increase in databases and web portals, which are very non-traditional PSC or HPC type works. So for bare metal booting, what do we use? We're looking at OpenStack Ironic. We've got some test deployments up, and we're starting to iron out the details of how we want Bridges to be booted. The great thing about Ironic and bare metal booting is that we don't pay any of the penalties of a hypervisor for doing virtualization technologies, but we get a lot of the models for managing images and managing all of these workflows and having different pieces that can work in unison. So this is really important for our data-driven model. We have, as Jerry said, a lot of people with these large data sets that need to be moved around, need to be processed, and doing something like that inside of a virtual machine is very very non-advantageous for the type of works that we do. Also with the Omni-Path, we want to be able to try to utilize this new high-fast interconnect to the full speed that we can get out of it. The other interesting thing with OpenStack is the manageability. We'll be able to dynamically provision portions of the cluster how we need to, whether it be a Hadoop environment or a traditional PBS batch system or any other type of image that a user may come to us with. So we get these repositories and these redeployable, customizable environments that we can handle on the fly.
I have a question about that, please.
Sure.
So is this not going to have a dedicated scheduler for the whole thing? Are you going to allow users to pick the scheduler they need, or how are you doing something that manages it, right?
Yeah, so basically Ironic will manage the OS deployments across different portions of the hardware. So we'll be able to segregate off a piece of hardware, and if that person wants to run in a traditional batch environment, we can spin up a PBS image with a server and then a bunch of PBS moms and computes, and let them have that group or pool of nodes to themselves, while over here someone may be spinning up a Hadoop cluster to do HDFS work and stuff like that.
So the work batch scheduler isn't the way of managing the resources of the node, that's just to make sure that their previous old job still runs.
Correct. We're going to be using this to carve off chunks of the resources Ironic will know the node properties, whether the nodes have GPUs in them or they're the larger memory nodes, et cetera. And then we can kind of orchestrate who gets what on the fly.
This ironic model, then you can only provide each tenant the complete hardware. You cannot have multiple tenants within code.
Correct, but we can spin up a node that's running an OpenStack hypervisor and then offer virtual machines on there as well.
But OpenStack doesn't support Omni-Path, right?
Well, the Omni-Path is external of OpenStack. I mean, but we can talk some about that later if we want.
It supports the OFED.
Right, it supports the OFED. I mean, OpenStack is going to be spinning up the underlying services. So whether you're in a virtual machine or on bare metal, if you're on bare metal, you can take advantage of the Omni-Path, as long as your image that you're booting has the Omni-Path drivers.
Yeah. But you can take advantage of the software.
Okay. The other thing that we're interested in doing is some of the newer features of OpenStack allow network tenant isolation. It's a way to take these different chunks of the machine we're carving off and to put them in entirely different IP spaces so that one user's jobs can't conflict with another's as far as utilizing the network. Then as far as virtualization, we do expect some users to come with their own VMs, their own entire setups, and they basically just want to scale them out a little bit more. So the idea is here is we can leverage the virtual machine infrastructure of OpenStack to do KVM, to spin up these custom environments, to allow simple scaling. Even though that you're not taking 100% advantage of the hardware, it gives them a larger pool to do some testing and eventually take that image and roll it into a bare metal deployment. So this is kind of a way to just get people running quicker on a larger scale, and then we can work with them for deploying on bare metal to get the full deployment benefits of the hardware. And with KVM, we've seen a lot of advancements with CPU pinning, being able to do pneumo scheduling to gain some speed. The SRIOV for being able to not take as big of a penalty hit for data movement on VMs. And then another hot topic, obviously, is Docker and containers. OpenStack has got a Docker integration support system as well. So we're looking at deploying this piece to be able to allow users that are coming with Docker containers to be able to run on bridges as well. The great thing about Docker is it can help you scale your deployments, but also there's no hypervisor. You're basically running on the bare metal with really limited overhead. You don't need SRIOV, and you can be able to take advantage of the full Omni-Path. So these are some of the couple non-traditional type HPC environments that we see a lot of users coming to us with. The other thing, application support, web portals, as I said. We have a lot of community account type users that are coming in. They want a web portal. They want to be able to launch jobs from there. They want to be able to transmit their data without really being on the back end and knowing how a batch system works, knowing how to copy files around. So the web portals and the databases, being able to spin these up either through OpenStack, bare metal, or through a VM or through a Docker container to get these users up and running, but keep all of the pieces hidden from them about how it's actually deployed. Because at the end of the day, they really just want to get their jobs to run. They don't care how Apache's set up, how the database works, as long as they have access to it and can get their data. So I can take some questions now. I know I kind of flew through stuff a little fast, but if anyone has questions, we can talk. Sure.
What are you doing for high availability? Because OpenStack, you need to have multiple databases and RabbitMQ server high availability.
Right, so we're looking into an HA setup. For Ironic, one thing I'm looking at is doing it inside of Docker containers so that we can have failovers through the container, have the container propagated on a couple different servers and spin up as we need, or also doing HA through a traditional OpenStack setup as well.
And for the software-defined networking, are you going to use Neutron?
Right now, we're not using Neutron for Ironic, but we will be using it for the VM portion of OpenStack. There's a few kind of nitty-gritty details in Neutron that aren't really advantageous for the way we're doing the bare metal booting, but they will be for all the virtual machines and the Docker containers. The Ironic is basically we have our stand-up our own DHCPD server, and we allow Ironic to manage TFTP and Pixie and all of the images. So we're using Glance, we're using Nova to provision and everything. So Neutron's really the only piece we're not using in the Ironic deployment.
So you're using the traditional?
Yes.
Normal.
We're using DHCPD to do it. So we don't even need any of the networking pieces from OpenStack for the bare metal. Okay. Yes.
Will there be data supercell /2 available for bridges? And if so, how do you plan to integrate it across the different things you talked about, such as Docker?
That's a good question. So we will have /2 available alongside of like some kind of a Lustre deployment as well. The goal for that is I have some projects on the side that will be doing certificate-based authentication for /2. It'll basically Kerberos or MyProxy, and once that gets glued in, then you'll be able to mount /arc or whatever you want, the archiver, in your VM, and then you need your Kerberos or MyProxy certificate or credential in order to access the file system.
Again, for some that don't know, /2 is a file system that we've developed at PSC that it was designed for wide area file systems work, so geographically very dispersed work. And as we go into bridges, we'll be looking at /2 as a way to tie together systems from other centers. I mentioned that Exceed project. So as we have more partners, they'll come into a globally distributed shared file system. Then for local performance, we'll have a Lustre file system that we'll be using. And that's another feature that we like very much. There is a Lustre deployment for Omni-Path native. Basically uses the LNet layer over Omni-Path, and so we'll be able to take advantage. There was the questions earlier talking about how we'd be using the Omni-Path. While we will be providing some MPI support on the system, that's not the primary. So the primary users will be people who are single node users, and for them what we want to do is make sure we have very good I/O. There will be local storage on all the nodes, but we also want to have a high performance shared storage environment, and that's where we'll go to Lustre over Omni-Path, and the /2 will also work there as well.
Follow-up question to the /2, if I could.
Sure.
So you're going to use /2 to get data replication across Exceed sites and not something object-based?
Well, /2 is object-based, yeah, and so we will be using it. It's not an Exceed adopted project, but we have partners within the project of our own that we're working with.
Yeah, under the hood, it's broken down in 128 megabyte BMAP regions, and we can replicate on any portion of the file or the entire thing. So you can ship different pieces of the file to different places. So if you have a large data set that, a couple, like 100 terabytes, and you only need the first 5 terabytes, we can replicate the 5 you need geographically to the place where you're going to do the computations on. Sure.
I'm curious what OS you're using, and Liberty just released, so I think you're using the upstream from OpenStack.
Yeah, we're deploying on CentOS 7. We're doing the install through PackStack, and we're using a modified Liberty right now. So there's some code changes, some bugs and stuff I've been following since Havana days. But we've been kind of rolling up as we are, and the Liberty version of Ironic has a lot of bug fixes that solve a lot of problems that we saw in Kilo. So it's way more stable, and the couple patches that I needed to put in aren't very big. And there's a few more Neutron things I need to sort out with disabling it entirely for the Ironic portion. But Liberty's pretty much good to go. If you have questions about it, we've been through a whole bunch of the different setups. We have notes, we've got all kinds of the gory details that we've been through if you're looking to deploy things.
Will you provide the loss of storage if someone comes in with some virtual machines that are already done? Will they need to compile their own loss clients for those machines if possible, or use any other?
That's a good question. We're hoping for some of the images we can bake in, these pre-packaged images for like Hadoop or for PBS or other jobs, that we can have the Lustre kernels built inside of it. The way Ironic works is it takes your image and it launches the node you're going to run on, and it mounts it via iSCSI and streams the image onto the local disk, reboots. So whatever is in our image is what's going to be baked on the back end, minus some last minute things that'll be done through Puppet, configuring the networks, the Omni-Path, and potentially things like the file system tweaks for each individual host. So yeah, we have a couple things we need to look at, but we're hoping it should be pretty easy to bake it into the images, minus maybe some kind of authentication stuff on the top of that.
So would you do some extra work with someone besides some images, you guys, get it through your images, prepare it from?
Right, the goal is for us to kind of maintain the images for the user so they don't have to. We'll have a pool of general purpose type images to deploy certain nodes. If they have their own that they're coming in with, we'll probably have to work with them, to see if, get the right software on there for doing /2 or Lustre, et cetera. So there is some user support that's going to happen for the custom images, and there's not really a great way around that other than just, working with your users.
In your architecture, you don't need Cinder, right?
Correct. We may use Cinder for the virtual machine portions. If somebody would like to have block I/O attached to their VMs, and then keep it separate so when they spin new VMs up maybe 6 months down the road, they can reattach their storage and have their data there. But for the Ironic portion, no, we won't need Cinder. We just use Glance to store all of the the booting images.
And also you can hold the dust up,
Right. Any other questions?
I might just mention, talking about the storage, that while we are supporting, of course, as Bob mentioned, all the VM work, we do see for our users that anybody that's going to be doing some of the serious data work that I discussed, that won't be through the VM. That'll be just on the native node. So there'll be this graduation of people coming in potentially with their own VM, but as soon as they, we get it worked out, then they will end up on bare metal nodes. They won't be virtualized nodes, and they'll be running native, and then that's how they'll move forward. I think it's a very interesting time. I'm in the management of the Exceed and the PSC, and our colleagues, you might want to, if you're going to be at the supercomputing show, there's 3 systems now that are coming out of the National Science Foundation. There's the Comet system, which is from San Diego Supercomputing, SDSC, and then Jetstream, which is coming out of the Pervasive Technology Institute at Indiana University, IU, and then ours. And we all have very similar ideas and overlap, but then we also all go our own direction. So Comet is doing virtualization, but not over provisioning nodes, and so they have islands of clusters. So that'll be a very interesting system to look at. So if you were doing a lot of MPI work, and you need a little cluster of your own, they will virtualize that, but their hope is to have very, very small performance impact in an HPC environment. Jetstream is a cloud solution for HPC, so that's the place where people will come and bring their own VMs and work, and then for the data solutions, that's where Bridges. So the 3 sites are going to be working very closely together, but if we had somebody that was very much into VMs, we would probably send them off to IU, or if they were very MPI intensive, we would send them, we wouldn't send them anywhere, but the NSF would put them on the Comet system, and then the other users would come to us. And that's the advantage of this Exceed program that I was talking about, is we have 3 separate centers, but we can work together as one.
And the great thing about some of the OpenStack stuff is the VMs can be used almost to get your jobs up and running, and then you can take that image from a VM, you can clean it, and then you can push it out on bare metal. OpenStack kind of has some tools to do this pretty seamlessly. So we're hoping that you can get users started in VMs and then shuffle them off where they need to be, or come to our site and run on bare metal.
About how many users do you expect the program to cover?
How many users?
How many users?
So, Yeah, we typically will, I would expect that we will probably end up with around 1,000 or so users. We tend to think in research groups, so there'll probably be about 100 different research groups that we'll have, that we'll be working with.
Sorry, one follow-up. The utilization, do you know about what percent you expect it to be? I mean, is it pretty much 100% or what's the projection?
Yeah, we expect, this system's been in the planning for 2 years, and so the anticipation is very high, as always, and we expect to be, very, 100%'s never, we never quite get there, but we typically shoot for, full utilization, including overheads and maintenance times is usually considered about 80% of clock time, so that's usually about what we all hit. That's a question.
Are you using Keystone for authentication or Tarmac?
For the VMs, we've used Keystone. For the bare metal, we'll probably wind up using Kerberos. For the starting stages, we're not going to have the users have root on a lot of the PSC baked images, so we'll be able to manage that a little bit more at our layer. But for the virtual machine stuff that they're going to bring in, yeah, sure, we'll use Keystone because it can integrate into LDAP and our Kerberos backend, so we can get in and help them if they need to. But also, we can give them their own permissions to kind of go off and do what they need to do.
Yeah, giving users root on VMs is a very hot issue, at least in our community.
Luckily, we have a security team that deals with that, and
Yeah.
I can.
OpenStack provides own security, right?
Yes, they have their own security stuff for doing firewalls and that sort of thing to kind of lock things down.
Even if we give the root privilege, we can still have
Right, right.
But things like shared file systems are hard to do in those environments.
Yeah, that's the big thing. That's where any kind of file system you want has got to be certificate based. Otherwise,
With Liberty, you can find the advanced images too.
I'm sorry, what?
With the Liberty, you can even find the advanced images.
Yes, you can sign the images. There's also, in some of the Ironic, you can have it check the firmwares. So when you tear down a cluster and do the next one, you can have Liberty sign the firmwares, check them, check the BIOS, check all kinds of other firmwares on different hardware pieces to make sure that a user didn't maliciously upload a custom firmware into the machines. So there's a lot of provisioning things that you can handle, that it can handle for you.
But right now, we're just trying to encourage users not to need root. If they do need root, we send them to Cleveland. So. Okay, if there's no other questions, I want to thank Brock Taylor for the invitation to speak with you. We do have a booth. PSC has a booth over at Supercomputing. We have an example of each node that will be in Bridges in the booth up and running, including then the Omni-Path interconnect. So if you want to come and talk to us about how Omni-Path is, not too much to see in a network, you can look at the cable. But we have some monitors to show us how it's working. Our PI for Bridges is Dr. Nick Nystrom, and feel free to contact Nick if you have any questions, or of course the co-PIs, including myself or Robert. So, again, thank you very much.